Welcome to today's class. Today we will be discussing Industry 4.0 Environment and Design Principle. So before we begin, let us understand the difference between conventional automation and the Industry 4.0. Let's explore the concept in more detail. Let us learn what is actually conventional automation. So conventional automation refers to the use of machines, robotics, and control systems to perform tasks with minimal human intervention. This form of automation has been in existence for several decades and has greatly improved productivity and efficiency in industries. Industry 1.0, 2.0 and 3.0 are all a result of this kind of conventional automation. However, conventional automation primarily focuses on replacing manual labor and streamlining specific processes without extensive connectivity or data-driven insights. Now compared to that, if we consider Industry 4.0, Industry 4.0 on the other hand represents a paradigm shift in automation by leveraging digital technologies, connectivity and data analytics to create smart, flexible and interconnected systems. It is characterized by the integration of cyber-physical systems, Internet of Things, cloud computing, artificial intelligence, big data analytics, and machine learning. Now, in order to understand the difference between the conventional automation and the automation in Industry 4.0, I'll show you some videos. So in order to understand the difference, let us first look into conventional automation. This is an example of some industrial robots which are working at Audi. So these videos that you see here are some of the examples of these conventional automation robots. You can specifically see that a particular robot is designed to do a specific task. Although they are connected through the industrial buses, and most of the data actually resides in the company's own cloud. So you can see the robot is actually doing some pick and place operations, and it has been designed for that purpose only. And you can see the products are quite standard, like let's say a few models of vehicles are being designed. So the robots are actually programmed to do those specific tasks and work with specific vehicles. If there is a welding robot, it can only do welding. So specific operations are actually defined for the different robots. Now that we have learned what is conventional automation, let us look into Industry 4.0 based automation. So this is an example of automation in Industry 4.0. You can see that here the products are not standard, rather the consumer chooses what product he or she has to make. Once the order is received by the company, all the specifications and the requirements are specified here. Next, the smart factory actually tries to find out the materials that are required to make the product, and in which factory it has the machines to manufacture it. So as you can see, it has found out few components which were not in stock, and those components are to be ordered. And now you can see a drone is delivering those products which are actually out of stock. One thing you can note is all the operations are being done autonomously. Once the packages have arrived, a robot is actually looking into, or a drone is actually looking into the different boxes that have arrived, and it is trying to assess if there is any damaged packages. So once a damage has been detected, it will then ask the human operator to take a decision whether to keep the product or return it. So as you can see, the operator has actually rejected the damaged package. So once all the product arrive, the next job will be to manufacture the product. You can now see that forklifts are moving the components to different workplaces. Fully autonomous robots are actually moving the objects to different places in the factory. They are also detecting obstacles, and actually as you can see, the robot has avoided hitting a human here. Then you can see different components being manufactured using additive manufacturing, which is nothing but 3D printing. So once the different components of a product are designed, it will be assembled, and then it will be once it is completed, it will be delivered to the customer. So from this video, there are a few things that are quite clear. Let us discuss them. Let us first discuss the characteristics of conventional automation. Conventional automation is task-specific automation. The first characteristic is this. Machines and robots are programmed to perform specific tasks repeatedly, such as assembly line operations or material handling. Like we were seeing robots which were doing specific tasks. A welding robot was only doing welding. Then the second characteristic is limited connectivity. So conventional automation systems often work in isolation and have limited communication and connectivity with other machines or systems. Third is centralized decision making. Decisions are usually made by human operators or a centralized control system based on some pre-programmed instructions or a simple rule-based logic. Then the fourth characteristic is limited data utilization. While data may be collected during automation processes, it is not extensively used for real-time monitoring, analysis, or optimization. So these are the characteristics of conventional automation. Now let us look into the characteristics of Industry 4.0. So first one is cyber-physical systems. Mostly Industry 4.0 is based on cyber-physical systems. Physical machines, devices, and sensors are connected to digital systems, enabling real-time data exchange and decision making. Then it is also based on Internet of Things, virtualization. So connected devices and sensors gather vast amounts of data from various sources, facilitating seamless communication and collaboration between humans, machines, and systems. So this enables a virtual copy of the smart factory, which is created by linking sensor data, which is collected obviously from monitoring physical processes, with virtual plant models and simulation models, like in the case of that Siemens smart factory we were seeing. Next characteristic is decentralized decision making. So intelligent systems and algorithms empower machines to make autonomous decisions based on real-time data, enabling agile and adaptive manufacturing processes. We were seeing that a forklift was avoiding hitting a human when it was transferring some crates to a manufacturing zone. Some other characteristics are data-driven insights, real-time time capability. So advanced analytics and machine learning algorithms analyze the collected data to generate actionable insights, optimize the operations, predict maintenance needs, and improve overall performance. Actually, here in Industry 4.0, once we gather enough amount of data from the machines, we can find out when a failure might be happening, and accordingly we can actually prepone the maintenance schedules of machines according to the needs. Then the next characteristic is enhanced human machine interaction, service orientation. So Industry 4.0 envisions human and machines working together harmoniously. Right now, actually, if you see, normally robots and humans are separated in factories, if you consider the conventional automation. However, with this Industry 4.0, it envisions that human and machines will be working together harmoniously, with humans focusing on complex decision making, creativity and problem solving, while machines handle repetitive and data intensive tasks. Okay, so next characteristic is customization and flexibility, that means modularity. So Industry 4.0 enables efficient production of highly customized products through flexible manufacturing processes that can adapt to changing customer demands. Like in the previous video, we saw that there are no standard products in Industry 4.0. In fact, a consumer can provide his or her own choice, and accordingly a product can be manufactured. For example, right now if you buy a car, it normally comes in standard colors or with standard features. With Industry 4.0, a consumer or a customer who is purchasing a car can not only choose the color, he or she can also select the different features in a car and can give an order, and accordingly the smart factory will be manufacturing that product. Now let us have a look on the design principles of Industry 4.0. When designing an Industry 4.0 environment, it is important to consider the following principles. First is interconnectivity. The foundation of Industry 4.0 is interconnectivity, where machines, devices, sensors, and systems are connected and can communicate with each other in real time. This enables the seamless flow of data and information across the entire production process, facilitating automation, optimization, and decision making. So this is actually one of the important factors that separates the Industry 4.0 from conventional automation, this interconnectivity. Next is information transparency. Industry 4.0 emphasizes transparency by making relevant data and information accessible to all stakeholders. It involves capturing, storing, and analyzing vast amounts of data from various sources to gain insights, monitor performance, and support decision making. This transparency actually enables improved visibility, traceability, and accountability throughout the production and supply chain. Next is decentralized decision making. Industry 4.0 environments employ technologies such as AI and machine learning to provide technical assistance and enable decentralized decision making. Intelligent systems can analyze data in real time, assist operators in their tasks, and make autonomous decisions based on predefined rules or algorithms. This leads to increased efficiency, agility, and adaptability in the production process. Another important parameter or principle is the flexibility and modularity. Industry 4.0 promotes flexibility and modularity in production systems. The ability to quickly reconfigure and adapt production lines, machinery, and processes to meet changing requirements or customer needs is crucial. Modular systems and components allow for easy integration, upgrades, and scalability, enabling agile responses to market needs. So as I told, like here the factories are actually quite reconfigurable. So whenever there is a need of a particular product, accordingly the assembly line can adapt. So next important principle is the cyber security. Since we are actually connecting a lot of these machines with each other, so this cyber security is actually very important. So with increased connectivity and digitization, Industry 4.0 environments face cyber security challenges So protecting sensitive data, intellectual property, and ensuring the integrity of systems and networks is essential. So robust cybersecurity measures, including secure communication protocols, data encryption, access control, and threat monitoring are critical to mitigate risks and ensure the reliability and resilience of the industrial infrastructure. Next important principle is the human-machine interaction. Industry 4.0 recognizes the importance of human involvement and collaboration with machines and intelligent systems. Effective human-machine interaction involves intuitive interfaces, visualization tools, augmented reality, and virtual reality technologies that enhance the user experience, facilitate training, and support decision making. That means there is a whole new level of interaction between human and machine in the case of Industry 4.0. Even before a product is designed for you, you can visualize that particular product using the virtual reality and related technologies. Next important characteristic is the continuous improvement. While our conventional systems have some sort of improvement, that means if you have designed a product and you want to make some improvement, normally you have to wait till you come with another version of the product. But here in the Industry 4.0, you can have continuous improvement. So Industry 4.0 environments promote a culture of continuous improvement and learning. Through the collection and analysis of data, organizations can identify inefficiencies, bottlenecks, and areas for optimization. Continuous monitoring, feedback loops, and data-driven decision making allow for ongoing enhancements to processes, products, and services. That means if you have enough data, and let's say you have launched a particular product, and you have enough data about that particular product, you can know how the market is actually behaving to your product, what are the lacunae in your product, and accordingly you can modify your product. So you have the option of continuous improvement here. So when designing an Industry 4.0 environment, these principles should guide the selection and integration of technologies, processes, and organizational structures. It's important to align the design with specific business objectives, considering factors such as cost, feasibility, scalability, and the unique requirements of the industry or domain. In summary, we can say the concept of smart manufacturing facility demonstrates how the integration of physical processes with digital technologies can lead to better productivity by enabling real-time monitoring, data analysis, proactive adjustments, coordination, and predictive maintenance. Some other examples are like this. There's an example from Siemens. If you have seen that previous video, it was a Siemens smart factory concept. However, this is some other product. So German manufacturing giant Siemens, an industrial user, is implementing an Industry 4.0 solution in medical engineering. For years, artificial knee and hip joints were standardized products, with engineers needing several days to customize them for patients. Now new software and steering solutions enable Siemens to produce an implant within 3 to 4 hours. You can see how the Industry 4.0 is optimizing this manufacturing process. Similarly, German tool maker Trumpf, an Industry 4.0 supplier and worldwide market leader of laser systems, has put the first social machines to work. Each component is smart and knows what work has already been carried out on it. Because the production facility already knows its capacity utilization and communicates with other facilities, production options are automatically optimized. So we'll now look into some of the mega trends in this domain. In mega trends, we will be looking into some physical mega trends as well as some digital and biological trends. So if we discuss the physical mega trends such as 3D printing, new materials, drones, and robotics play a vital role in driving the transformational impact of Industry 4.0. These technologies are at the forefront of the digital revolution. revolutionizing manufacturing processes, supply chains, and product development. Here is how each of these trends contributes to Industry 4.0. So initially we'll start with 3D printing, which is otherwise known as additive manufacturing. So 3D printing is a game changer in manufacturing. Like I was talking in the previous lecture, that previously the kind of manufacturing we were using was subtractive manufacturing, where there was a lot of waste. Compared to that, additive manufacturing actually doesn't create much amount of waste. Okay, so 3D printing is a game changer in manufacturing, as it allows the creation of complex and customized products with reduced lead times and material wastage. This technology enables rapid prototyping, on-demand production, and decentralized manufacturing, making it cost-effective and efficient for various industries. 3D printing is instrumental in achieving mass customization and supporting agile production processes. The next physical trend is new materials and composites. Advances in material science, including the development of new materials and composites, are key enablers of Industry 4.0. These materials offer improved mechanical properties, enhanced durability, and increased functionality. They allow for creation of lightweight yet robust products, contributing to energy efficiency and sustainability. New materials are also crucial for enhancing the performance of components used in robotics and drones. Similarly, the next physical megatrend is the drones and unmanned aerial vehicles, or UAVs. So drones have transformed various industries by providing innovative solutions for monitoring, data collection, and logistics. In Industry 4.0, drones are used for asset inspection, like we were seeing in the earlier video, then surveillance, precision agriculture, and last mile delivery in e-commerce. Drones enable real-time data acquisition, reducing operational costs and enhancing safety in industries like construction, agriculture, and transportation. Another megatrend is the robotics and automation. Robotics is at the core of Industry 4.0, driving increased automation and productivity. Robots and autonomous systems are employed in manufacturing, warehousing, healthcare, and various other sectors. They perform repetitive and dangerous tasks, improving quality, consistency, and workplace safety. Similarly, another trend is sensors and IoT connectivity. The proliferation of sensors and the Internet of Things, or IoT connectivity, enable real-time data collection and monitoring across industrial systems. It is actually IoT that allows for seamless integration and communication between devices, enabling intelligent decision making. Another physical megatrend is the advanced manufacturing techniques. So Industry 4.0 encompasses a range of advanced manufacturing techniques such as laser cutting, CNC machining, and advanced forming methods. These techniques offer great precision, accuracy, and efficiency in production, supporting the realization of complex designs and reducing material waste. Similarly, additive manufacturing will be also integrated into these advanced manufacturing techniques. The next is the digital twin technology. So digital twin technology creates virtual replicas of physical assets, products, and processes in the digital world. It allows for real-time monitoring, predictive maintenance, and optimization. By analyzing data from the digital twin, organizations can enhance product design, performance, and operational efficiency. Energy efficiency and sustainability is another trend. So mega physical trends in Industry 4.0 contribute to energy efficiency and sustainability efforts. Advanced manufacturing processes, lightweight materials, and optimized logistics reduce energy consumption and environmental impact. Similarly, let us look into the digital megatrends. In the digital megatrends, the first one is Internet of Things or IoT. So IoT plays a pivotal role in Industry 4.0 by enabling smart manufacturing and predictive maintenance. So connected sensors in machines and equipment provide real-time data on their performance, allowing manufacturers to monitor operations, identify potential issues, and optimize production processes. Predictive maintenance based on IoT data helps prevent costly breakdowns by allowing maintenance to be performed proactively only when needed. Similarly, another digital trend is the RFID or radio frequency identification. So RFID is a technology that uses radio waves to identify and track objects equipped with RFID tags. In Industry 4.0, RFID facilitates real-time asset tracking, inventory management, and supply chain optimization. If we attach this RFID tags to products, components, or equipment, the businesses can gather better visibility of their assets. They can easily manage their assets. They can even trace their assets, which will obviously lead to improved efficiency and reduced errors in logistics and production processes. The next megatrend is this Bitcoin. So while Bitcoin itself may not directly impact this traditional manufacturing processes in Industry 4.0, its underlying technology, which is the blockchain, has far-reaching implications. Bitcoin is a decentralized digital currency, and its use and acceptance have sparked lightning trading and reliable transaction. So as I was discussing, so blockchain is another important digital megatrend. Blockchain is basically a distributed and immutable ledger technology that allows secure and transparent record keeping of transactions across a network. In Industry 4.0, blockchain can enhance supply chain transparency. Blockchain enables the execution of self-executing and tamper-proof smart contracts, which can automate various aspects of business processes such as payments, agreements, and compliance. So overall, these digital trends empower Industry 4.0 by providing real-time data, enhancing automation, improving traceability, ensuring data security, and facilitating smart decision making, ultimately leading to increased efficiency, productivity, and innovation in various industries. So we'll now look into some biological megatrends. So the first of the biological megatrends is synthetic biology. So synthetic biology involves the engineering of biological systems, including DNA, proteins, and microorganisms to create new functionalities or enhance existing ones. So in Industry 4.0, synthetic biology plays a crucial role in designing customized organisms for various applications such as bioremediation, pharmaceuticals production, and biosensors. Then precision agriculture is also one of the mega trends. Precision agriculture actually utilizes biological data, sensors, and IoT technologies to optimize farming practices. By monitoring and analyzing soil conditions, weather patterns, and plant health, precision agriculture enhances crop yield and reduces resource wastage. Actually, this makes farming more sustainable and efficient. Another one trend is the personalized medicine. So advances in genomics and biotechnology enable personalized medicine, tailoring treatments to individual patients based on their genetic makeup and other biological characteristics. This approach can lead to more effective and targeted therapies, potentially revolutionizing the healthcare industry. So when we talk about the industrial manufacturing, sustainability is one of the major issues, or sustainability is one of the major parameters. Sustainability is actually the core business strategy for future, as highlighted by the UN Sustainable Development Goals. They include fostering areas like low impact industrialization, energy efficient buildings, and smart manufacturing. That's where Industry 4.0 comes in, combining physical operations and production with digital technology, AI, and Internet of Things. So we'll be able to make our manufacturing more clean, more energy efficient, which will have low impact on the environment and the world. So let us now look into some of the Government of India initiatives on Industry 4.0. So India has been actively embracing Industry 4.0 technologies and initiatives to drive digital transformation and enhance its industrial capabilities. Several initiatives and programs have been launched by the Government of India and various organizations to promote the adoption of advanced technologies and foster innovation in the manufacturing sector. So here are some of the notable Industry 4.0 initiatives by the Government of India. As you can see here, there is a Center for Industry 4.0 C4I4 lab in Pune. Then there is a IITD AIA Foundation for Smart Manufacturing in Indian Institute of Sciences, Bangalore. They have a I4.0 India R&D platform. Similarly, government has established smart manufacturing and smart manufacturing demo and development cell at CMTI. Similarly, some Industry 4.0 projects are at DHICU Center of Excellence in Advanced Manufacturing Technology at IIT Kharagpur. For some of the success stories, you can follow this provided link. There are a lot of documents which highlight how Industry 4.0 has been implemented in different factories in India. So thank you for your patient listening. We'll meet in the next class.